Here they're asking us to simplify an algebraic fraction. So algebra and fractions can't get more fun than that, can it? Let's think of another example first. If I had 2/3 minus 1/4, you may remember that we need to think about making them have the same bottoms, or what we call a common denominator. So in this case, to make a common denominator, I could think about changing the 3 and the 4 on bottom. If I times them together, I get 12. So to make this work, what I do is I times this side by 3/3, and I can times the other side by 4/4. And when I times fractions, I just times tops and bottoms. So that becomes 4 times 2 is 8/12, and 1 times 3 becomes 3, and the bottom again is 12. And now that I've got the same bottoms, I can just write them as one thing over the same bottom. So it's 8 minus 3/12, which is in fact 5/12. Now the reason that I've written it like this, as times 3/3, is that really 3 divided by 3 is equal to 1. So if I times anything by 1, I haven't really changed what it represents, I've just changed how it looks. And that's a legal move. So the same thing applies here with our algebraic fractions. And the reason I'm thinking about making common denominators is because both of these terms are together, they're just on one side of the equal sign. And in fact, there is no equal sign here, I'm just looking to simplify these. So, as a similar idea, I have a 3 and a 5 on the bottom, so if I think about making a common denominator, I could times together a 3 and a 5 and get 15. So to turn the 5 over here into the 15, I need to think about timesing by 3/3. And I'm going to put brackets over that whole big fraction because I have to remember that the 3 times to everything over there. And on this side, I'm going to times by 5/5. So 5 times x will give me 5x over 15 minus, well, we have to use the claw here to make sure we times 3 by everything over there. So 3 times 3x gives me 9x. And then I have 3 times -2 gives me the -6. And that's still all over 15. And it might be worth our while to keep that bracket there. Because in fact, because those are over the same big fraction bar, they're kind of stuck together with invisible brackets. And the reason I'm paying attention to that is because I need to minus all of that stuff from the 5x with that minus sign there. So in fact, I need to expand out the minus sign as well. And you could think about that as being a -1 and timesing it through. So I have 5x minus times the 9 becomes minus 9x, and minus times a minus becomes a positive 6. And now it's all over 15. Okay, so then we're nearly there. Next thing we want to look for is like terms, or any of these things I can combine together. And in fact, the 5x and the 9x I can combine. So 5 minus 9 gives me minus 4x, plus 6 stays on its own, and this is all over 15. So there we have simplified the algebraic fraction. Now in some cases, people like to kind of ignore this 3/3. So if you wanted to look at it in a more simplistic version, minus 3x over 2, or minus 2/5, we can just break it down and think more simply that I'm going to times this side by 5 and times that side by 3, but make sure you do it to everything. So that's 5x minus 9x minus 6 over all over 15. But we have to be careful here, and you want to add those brackets in and keep them there because that minus sign needs to go through to both things. So same process, 5x, the minus goes onto the 9, and the minus becomes positive over 15. So we get -4x plus 6 over 15. Both workings will work, and technically they're doing the exact same thing, but some people find one a little less confusing than the other.